startups. I saw some CEO cards being passed around earlier. We're very used to thinking about scale in terms of going to a commercial scale plant where you show something's economic viability, right? That's the first step of what we need to do to bring a technology to market. The second step we do is we up the scale, large scale commercial, we drive the costs down, right? Very typical model of bringing technologies to market. That's the iPod, that's the computer, that's the car, that's the batteries, everything goes through this phase. And the scale I'm talking about is enough to displace fossil fuels. So when we talk about particular technologies, we want to know if it can scale up or not. Because if a company is going to take advantage of this global opportunity, and I'll show you how I think that might unfold, it needs to be aware of the size of this. I mean, to ask ourselves, is, especially when it comes to policy, what technologies can scale and what can't? So to drive your imagination in that direction in the book, I ask of each of the 10 technologies, what would you get for $1 trillion? What does the cost of energy come out at? What does solar thermal from big power plants cost when you build $1 trillion worth of them? What happens when you try to build $1 trillion worth of infrastructure for ethanol? Well, it turns out you can't, and you can't for wave power. Right? So there's some technologies that can deliver at the scale we need them to, and there's some that can't. The pace of growth, I think, and this is key as a venture capitalist, picking a company that's going to be able to take advantage of this growth. I don't think it's going to be linear. I don't think tomorrow will be like today for all kinds of reasons. I've gone over a few. I think there will be a highly nonlinear event that will accelerate the adoption of clean technology into the marketplace. We're seeing the beginning of that growth on the venture side before the economic disruption hit, that venture money was flowing into this sector. We're now going to see from events, policy and or events, money flowing in on the project side, creating demand for these technologies. Highly nonlinear. This is the interesting opportunity, I think, for companies. And the nature of that shape indicates there are going to be certain characteristics you want to look for in companies that you want to invest in, for example. You need an open-ended, commodity-based supply chain. If you're building a wind turbine that's reliant on rare earth metals, for example, you're not going to be able to sell into this accelerated market because there isn't enough rare metals. Lithium will face some of those same supply constraints. So that's one thing you need to take a look at. The other is that you need a simple and scalable manufacturing process. So nuclear will not be able to respond to this accelerated demand. 15-year cycle on building a nuclear plant. We're just not going to do it. Traditional solar PV, possibly. Those are big, complicated plants. There's a company out of Toronto called Morgan Solar, which I'm very interested in because I don't know how much detail to get into, but they essentially use very little silicon, and they build essentially injection molded bits of plastic that acts as a light guide to focus. It's concentrated PV. So their whole value proposition is I use existing injection molded equipment, so you can scale up manufacturing in a second, and I don't rely on a lot of silicon. So there's more than enough triple junction cells available for it. So that's another characteristic you'd look for in a company that can respond to this nonlinear growth. And of course, the big one is you need to be financeable, right? It's not entrepreneurs who decide what technologies get installed. It's not even project developers decide what technology gets installed in a solar farm or a wind farm or whatever. It's the bank. Banks' willingness to lend capital for projects is precisely what defines what technologies will be deployed at scale and what won't. And that's why I think green bonds really deserves a hit in Alberta, and I'll talk about that in a second. But you need to get your technical risk down, and as an entrepreneur, as a startup, you need to really wrap your arms around all stages of project risk. Almost to the extent that you need to act as your own customer to start, really, to get these things installed at scale, show the bank they work, have a relationship with banks that are already funding other renewable projects and have that conversation started, the day you're building your prototype. Because if you're not bankable, by the time this demand ramps up, you're not going to get installed, right? And what that event is going to be, and the reason I think it's going to be a nonlinear event, it could be policy driven. Right? It could be the United States deciding to try to catch up with China on Cleantech. China's spending $150 billion a year right now on Cleantech, more than any other nation. That could drive it. It could be a natural event. It could be another Katrina that wakes the public up, and so they demand a policy to come in. Or it could be peak oil, or a combination of these. But that's why it's going to be nonlinear, and these are the kind of characteristics you need to see in a company if they're going to be able to respond to that nonlinearity. And you need to leverage existing infrastructure. I think that's why carbon sequestration is more promised than delivery, unless you can find a way to use the sequestered carbon to produce a product. So instead of building a network of pipelines and burying it, there are people trying very hard to figure out how to make carbonate and build a new kind of cement or a new kind of building block or a new kind of drywall. And a company that solves that problem is a company that's going to be able to deliver on carbon sequestration. But the idea that we're going to build a network of pipes between every coal plant in China and bury that carbon in any kind of time frame that matters I think is hogwash in my view. But it's all hands on deck, so let's try it all. So the first way in which we're going to reduce our carbon footprint and kick the habit is efficiency. It's the least sexy clean tech. I mean, solar is sexy because it's producing electrons and wind, and I mean, these are the things we focus on. If there's not a single scenario put out by the Energy Information Agency or any other credible institution that talks about emission pathways, it doesn't assign at least a third to a half of the emission reductions to efficiency. And in my mind, so efficiency is not conservation, right? It's not putting on a sweater and lowering the temperature in the winter. I mean, that's a noble thing to do. It's doing without something. I myself don't hold out much hope that the general public is going to give up one iota of their creature comforts to solve this problem. So the solution in my mind is you have to solve the problem for them. You have to deliver efficiencies, you have to deliver energy. So efficiency is not conservation. Conservation is something noble, but I think not that effective. Efficiency is something smarter, right? A diesel engine is more efficient than a gas engine. Geothermal heating and cooling is more efficient than traditional heating and cooling. You're giving up nothing. You're doing the same thing, only more intelligently. And it's also an issue of economic competitiveness, right? So on this chart, you have, these are lines of constant GDP per unit of energy. So if you're on the right-hand side of the curve, you're more efficient. On the left-hand side, you use more energy. It's just an X1 of the X curve. So here we have Canada, uses a fair amount of energy per unit of GDP, probably twice what Japan and Germany do. There's a reason for that. Japan and Germany have had an effective tax on carbon since the Second World War. So in being more efficient, we're really moving along this curve. And we're producing more GDP per unit of energy, right? That's economic competitiveness. And this is very low-hanging fruit. The question is where China and India are going to go. The lower curve is obviously a less wealthy curve. And whether they're going to move towards the North American model or the European-Japanese model is an open question. And it is in those arrows movements that the economic opportunity lies. And this is the lowest hanging fruit. The economic arguments can be made today for efficiency. Things like, in Toronto, we use the bottom of Lake Ontario, the cold water down there to heat and cool our buildings instead of traditional air conditioning in a lot of the big ones. This is a building that I own. This is a project I've invested in. I'm the co-developer of Planet Travel, lowest carbon hotel in North America, I claim. Nobody's argued that it's not, so I'm assuming it still is. But we've lowered our carbon by 3/4 using traditional technologies, geothermal, solar thermal, PV, LED lighting, and we're making money doing it. Right? The loan payments on the infrastructure changes is less than the energy savings, so we're making money. Very low-hanging fruit efficiency. This is a building that's been reskinned, so it's a much larger version of what Planet Traveler is doing. And unless we invent something like airships, transportation is a problem. We can have smaller cars. France, they get twice the mileage as we do. They drive smaller cars. This is my favorite mode of transportation. I ride my bicycle. The thing about bikes is China and India, right? If those people get off their bikes and into cars, we are in a lot of trouble. It's unsexy. It's things like transit and bikes that we need to do to be efficient in our transportation. The electric car is talked about a lot, and I've been speaking to someone today who's developing an electric car. The real potential of the electric car, in my mind, is to get away from liquid fuels, but it's also to act